Today we're going to learn about the angle theorems for triangles. So in this unit we've been looking so far at angle relationships in general. So the last lesson was all about parallel lines cut by a transversal, and today is about triangles. So I tried to summarize it for you a little differently than the textbook did. So if you're doing this lesson in your textbook, I would suggest that you use these notes instead. There's two triangle relationships we're going to focus on in this lesson. The first one is the triangle sum theorem, which a lot of you already know already, that the angles in a triangle, all three of them add up to 180 degrees. So it's really helpful to know how many degrees are inside of a triangle, because if we know two of the angles, we can find the third. So written algebraically, angle 1 plus angle 2 plus angle 3 gives us 180. So we can find a missing angle in a triangle using this theorem. So I'm going to show you. It's very, very simple. If we know that one of them is 100 and the other is 55, and we're looking for angle E here, and we're trying to find what the measure of angle E is, we know that when we add the three of these up, it has to be equal to 180 degrees. So when the numbers are just given like this and they're not algebra, it's easy to just add the 155 and subtract that from 180. But we're going to be doing this using algebra going further. So I'm going to show you, we're going to use this setup. So you basically are saying angle 1 plus angle 2 plus angle 3 is equal to 180. And so you replace with what you know. So I know that one of them is 100, the other one is 55, and I'm trying to find the last one. I know it's going to be equal to 180. So this gives me 155 plus x equals 180. And then I subtract 155 from both sides. And x is equal to 25 degrees. So now I know that the missing angle is 25. Now I know a lot of you are not going to do it this way when it's just numbers, but I'm showing it to you like that for a reason, because when we're dealing with things that aren't numbers, they're expressions instead, this is the only way to do it. So I want to start you off doing it the right way. But it's very simple. So the your turn, these are still just numbers for now. We're going to find the missing angle measures using the triangle sum theorem. So 71, 56, and k. We don't know k. We're trying to find k. So we know that 71 plus 56 plus x is going to be equal to 180. So you add these two together. 127 plus x equals 180. And then we subtract 127 from both sides. And x is equal to 53 degrees. So that means that the measure of angle K is 53 degrees. Okay, and if you wanted to check, you could add them all back up and make sure that you got that as your answer. So you guys can pause and try this last one, and then unpause to check your answer. Okay, so when you add up the angles in number 5, 29 plus 61 plus x is equal to 180, you find that the missing angle is equal to 90 degrees. Okay, so this one is nice and simple. The second theorem is also simple, but it's different than what you're used to, so you're just going to have to bear with me here. This is called the exterior angle theorem. And this is a really helpful theorem for finding the measure of an angle that's outside of a triangle, or for finding the measure of an inside angle when you know the outside angle. So first things first, obviously we're talking about the word exterior here. So we are basing this theorem on the outside angle here. So this directly directly to the right or to the left, or even up here, anywhere, as long as it's right, it shares a vertex with one of these interior angles. So, what we know about the exterior angle is that it's equal to the sum of the opposite two. So wherever your exterior angle is, you look at the opposite two angles that are on the interior, and when you add those together, you get the exterior angle. So in this case, angle 4 is equal to angle 1 plus angle 2. If there was an exterior angle out here, this would be equal to 2 plus 3. And if there was an exterior angle out here, it would be equal to 1 plus 3. So, we can find a missing angle in a triangle using this theorem. This section, we're jumping right into the algebra. So, we're going to be using this setup instead of just trying to do it in our heads. Okay, so we know the exterior angle here is 52. And we're going to be figuring out what these two angles are equal to. So C right here is not important, but if we wanted to find it, we could, because what you'll notice is this is a straight line, and if I know this, then I know that the other piece has to add up to 180 degrees. So there's a few different ways that you can do this. You can use this theorem, which we're going to do here, but technically, if you know the exterior angle, a lot of the time you'll be able to say, okay, well, if this is 52, then I know what this angle is, and I know that the sum of these three is going to be 180. So I can also do it that way sometimes, but we're going to use the exterior angle theorem. So what I know is that the exterior angle is equal to the sum of the two opposite interior angles. So the two opposite interior angles are 3y and 4y minus 4. So, if I take these two interior angles and I add them together, 4y minus 4 plus 3y, it's going to be equal to 52. Okay, and now I just solve. I'm so sorry. So 4y plus 3y is 7y minus 4 is equal to 52. I add 4 to both sides, and I have 7y is equal to 56. Divide by 7 on both sides, and y is equal to 8. So if I know that y is equal to 8, I can now find these two angles by simply plugging in y. So 4 times 8 minus 4 is going to give me 32 minus 4, which gives me 28 degrees. So angle A is 28. And angle B is 3 times 8, which is 24 degrees. So angle B is 24 degrees. Okay? And it's really the measure of angle A, measure of angle B. And that's how you would solve it. So a few things before we move on. I've told you guys a bunch of times that solving equations is going to be necessary for everything that you're doing in the future. Geometry, it's still used a bunch. So even when you get into high school and you're doing 10th grade geometry, which hopefully you'll be doing in 9th grade, you're still going to be needing to know how to solve equations and do all of this fun stuff. So anyone who is still not solving their equations like this, I'm telling you now, you're going to be in trouble. So you have to start doing it the way that I've been showing you for 2 years now. Also, the other thing I was going to say is that these two theorems, the exterior angle theorem and the triangle sum theorem, you need to know those for geometry in high school as well, okay? And it will be assumed that you've learned it already, so make sure that you pay nice, close attention to this lesson. It's kind of a really important one, just like I told you about the parallel lines cut by transversals lesson, also super important for high school. Okay. So we're going to do the your turn together because I did include a bunch of practice problems for you guys to do. So we'll do this one together. We're going to find the measure of angle M and the measure of angle N. So what you can see is you have an exterior angle here, and this exterior angle I know by my exterior angle theorem is going to be equal to the sum of angle M plus angle N. So what I know is that angle M is 5y plus 3 plus the measure of angle M. So I'm actually going to write it out first. The measure of angle M plus the measure of angle N is going to give me 146. So angle M is 5y plus 3, and then angle N is 4y plus 8, and that's equal to 146. And now we can solve. So you just combine your like terms. I have 5y plus 4y, so that's 9y, and then I have 3 plus 8, so that's 11, is equal to 146. And then we just solve the equation like we always do. Subtract 11 from both sides. I have 9y is equal to 135. Divide both sides by 9. And y is equal to 15. So just be careful. They're not looking for y, they're looking for the measure of angle M and N. But once you know that y is 15, now you can plug it in and find your alternate measurements here. So for angle M, sorry, I put it on the wrong side. We know that it's 5y plus 3, so it's going to be 5 times 15 plus 3, because we have just learned that y is 15. So 5 times 15 is 75, plus 3 is 78. So the measure of angle M is 78 degrees. And the measure of angle N is 4y plus 8. And we're going to replace y with 15. 4 times 15 is 60, plus 8 is 68 degrees. So the measure of angle N is 68 degrees. A few things to note before we move on. You do want to get in the habit of writing measure of angle, whatever the angle is. The little m means measure of. If you don't remember that from the previous lessons, write it down somewhere. Measure of angle. Okay, that's what that means. Also, you always need to remember your degree symbols. That's important. And make sure you show as much work as possible. You don't want to attempt to do this stuff without actually showing any work, okay? You have to solve this and actually calculate the answers. You can't just guess what two numbers are going to add up to 146. Okay, so I have gotten a few problems from I think this is actually all from the guided practice. Yeah, this is all from the guided practice, and we're going to try one of each, and then you guys are going to try the other ones from each section. Okay, so for number 1 and 2, we're finding each missing angle measure, and this is the triangle sum theorem. Okay, so this one is simple numbers, and the next section is going to go into the algebra. So for number 1, I know that the measure of angle M, oh my gosh, plus the measure of angle L plus the measure of angle N is going to give me 180 degrees. So I don't know M, I'm trying to find it. I know 78 plus 31 plus X is going to give me 180. So 78 and 31, that's going to give me 109 plus X equals 180. And when I subtract from both sides, I find that X is equal to 71 degrees. So that means that the measure of angle M is 71 degrees. Okay? For the next section, we're using the triangle sum theorem again, but this time we are going to be finding each angle measure because we don't know any of them. All we know is the algebraic representations of them. So again, I know that the measure of angle T plus the measure of angle U plus the measure of angle V equals 180. So I'm going to replace it with what I have. So angle T is 7x plus 4. And measure of angle U is 2x plus 5. And angle V is 5x plus 3. And that's equal to 180. So now we're just going to combine some like terms here. I've got 7x, 2x, and 5x. Oh, sorry, that's oddly. That should be a plus sign. I accidentally wrote an equal sign there. If you guys wrote that, please change it. Okay. So 7x plus 2x is 9x plus 5x is 14x. And then we have 4 plus 5 plus 3. So that's 4 plus 5 is 9 plus 3 is 12. So we get 14x plus 12 equals 180. So I subtract 12 from both sides, and I get 14x is equal to 68. Sorry guys, so this is 168. I forgot to add the 1 before. We're dividing both sides by 14, and you find that x is equal to, this is going to give you 12. So now we know x, and we can find each of these angle measurements. So let's start with the measure of angle T. You might need some extra paper for this lesson. Measure of angle T is 7x plus 4. So if x is 12, we replace it here. 7 times 12 is 84, plus 4 is 88 degrees. So the measure of angle T is 88 degrees. Next, the measure of angle U is represented by 2x plus 5. So we replace the x with the 12 again. And this gives us 24 plus 5, which is 29 degrees. So the measure of angle U is 29 degrees. And finally, I need some more space myself. I'll just do it right here. The measure of angle V is equal to 5x plus 3. Replacing 12, we get, this is 60 plus 3, 63 degrees. And those are our 3 angles. And you can check that if you need to by adding them up and making sure you do indeed get 180 degrees. Okay, and the final example here for you guys is using the exterior angle theorem, and we're going to find the measure of each angle. So I've got my exterior angle here, it's 116 degrees. So I know that's going to be equal to the sum of the opposite two. So 4y plus basically the measure, let me write it out, the measure of angle C plus the measure of angle D is going to give me my exterior angle, which is DEF, measure of, did they call it DEF? Now just to tell you, the reason why these two angles only have one letter and this one are named with 3 letters is because remember that if an angle shares a vertex with another angle, you have to be able to name which one is which. So I can't just call it angle E, because if I call it angle E, I don't know if I'm talking about this angle or this one. So I say DEF to show that I'm talking about this one, and I say DEC to show that I'm talking about that one. Okay? So I'm going to use this piece of information to help myself find this answer. So the measure of angle C, I'm actually going to move this down here because I think I have a slightly more room. The measure of angle C is 4y plus the measure of angle D, which is 7y plus C, 6, is equal to the measure of angle DEF, or my exterior angle, which is 116. Okay, so I combine my like terms. I've got 4y plus 7y. That gives me 11y plus 6 equals 116. Subtract the 6 from both sides, and I'm left with 11y equals 110. Divide both sides by 11, and you find y is equal to 10. And now that we know that y is equal to 10, we can plug it back in and find all these values. So let's find the measure of angle C first. It's 4y. So I just replaced the y with a 10, and the measure of angle C is 40 degrees. The measure of angle D is given by 7y plus 6. Replace the y with 10, and we get 70 plus 6, or 76 degrees. Now there are two ways you can do this last one. If I know that these two angles are 40 and 76, then I know that the last angle has to add up to 180. So I can add those two together and then subtract. Or I know that this right here is a 180 degree, these are supplementary, because they make a straight line. So 116 plus this angle has to equal 180. So saving a step of adding these together, you can just do 180 minus 116, and you get 64. So that last angle is 64 degrees. Okay? So now that you've seen one of each, I want you guys to pause this, and I want you to try the second column almost. So this one, number 2, number 4, and number 6. Okay? Give it a shot and then unpause it. Okay guys, so here's the solutions. Number 2, you should get 30 degrees. And remember, I know it's a pain to set it up like this, but it's the best way to do it so that you can get used to doing all this work. And also, when you end up taking the geometry regents, eventually you have to show that in order to get full credit. So measure of angle Q is equal to 30 here. For this next one, you know that the sum of angle X, angle Y, and Z is going to equal 180. So you write that out. Measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180. And replace them. N plus 1/2 N plus 1/2 N equals 180. Of course, a half and a half is a whole. So that's like 1N plus another N. So it's 2N equals 180. Divide both sides by 2. And you find that N is 90. So N is same as angle X, so we know measure of angle X is 90, and then 1/2 of 90 is 45, and these are each the same, so it's 90, 45, and 45. And finally, our exterior angle theorem question. I see my exterior angle here, so I know that this is equal to the sum of these two opposite interiors. So I wrote it out. The measure of angle L plus the measure of angle M is equal to the measure of angle M, K, J, or you can call it JKM, it doesn't matter, as long as the K is in the middle. So after all the work, you set it equal 18Z plus 3 plus 5Z minus 3 equals 161. When you solve it, you find Z is equal to 7. And then when you plug everything in, you find that measure of angle L is 129, measure of angle M is 32, and LKM is 19. Okay? So guys, it's actually very easy stuff. It's just a matter of it being a lot of work, and in some cases kind of tedious. So just make sure you follow all the steps. Make sure you give yourself enough room on the homework. You're probably going to need a separate piece of paper, so please make sure you upload a copy of that for me to see. Okay guys, have fun.